In this video, we'll walk you through the process of configuring articulated props using static meshes. Creating blueprints with skeletal meshes will be covered in a separate video. We will create two simple blueprint examples. First, a pair of boxes connected by a hinge joint with limits. Second, a simple static mesh of a vehicle on wheels with suspension, showcasing how physics can interact with Unreal's control rig and animation blueprint. Let's get started. Open the content browser and find an appropriate folder. Create a new actor blueprint and name it. Double-click to open the new blueprint. Add a Newton rigid body as the root component. Enable debug mode and assign a mass value. Select the rigid body and add a cube mesh. Add a Newton hinge joint to the rigid body. Duplicate or add a rigid body and make it a child of the hinge joint. Make sure its mass is set. Duplicate or add another cube mesh and make it a child of the new rigid body. Select the hinge and position its relative transform. Select the child cube mesh and position its relative transform. Select the hinge joint and enable debug mode and limits. Set the hinge joint's angle limits. You may want to scale the debug gizmo if it's occluded by geometry. Select each cube and add a Newton collision. Choose convex hull for simplicity. Compile the blueprint and test the prop in the level. We are now ready to make a simple robot vehicle with suspension. In the content browser, navigate to the Vehicle/Offroad folder, right-click, and create a new actor blueprint. To help identify the different nodes, it is useful to use a naming convention. Open the blueprint. Add a Newton rigid body to serve as the chassis. Enable debug mode and set the mass, 1,000 kilograms for this demo. Add a static mesh and assign the SM off-road body Unreal asset. Add a convex hull for collision shape. Turn Show Debug off. Add a Newton wheel hinge. Configure the suspension. Set 2000 for spring constant, 60 for damper constant, 0.25 for the regularizer. These values creates a critically damped suspension. Add a Newton body as a child of the wheel hinge. Set the mass to 25 to 50 kilograms. We will use 40 kilograms. Add a static mesh component as a child of the new body and assign the SM off-road tire asset. Add the wheel collision shape, adjusting the rotation matrix and dimensions. Repeat this process starting from the hinge to create the wheel chain for the other side of the vehicle. Select the two joints and position them on the front side of the vehicle. Duplicate the setup for the remaining tires, adjusting parameters as needed, e.g., rotate the tire mesh 180 degrees to align it properly. Compile, and save your work. Go to the level editor and place an instance of this blueprint and test it. If necessary, tweak the joints and collision parameters until the vehicle feels right. We are now ready to add the animated suspensions to the vehicle. Open the blueprint in the content browser. Select the chassis rigid body and add a skeletal mesh. Assign the SCAM off-road asset, which contains the animated parts. We can now visually position each wheel joint to match the physic hub bone of the skeletal mesh. In the content browser, make a copy of the existing off-road control rig asset and open the new control rig. Control rig allows animators to create procedural poses and manipulate specific bone transform. For detailed tutorials on this, refer to online resources. In this demo, we will adapt the rig to be controlled by the suspension positions. Delete the default inputs. Select all 4 physics wheel bones and create a new control for each of them. Add a control gizmo for easier visualization. Traditionally, right side controls are red and left side controls are blue. Update each position constraint node to use the new controls instead of the physics wheel bone. Test the rig by moving the controls up and down. See that the moving parts animate correctly. Compile and save the rig. We now create the animation blueprint. In the content browser, right-click to create a new animation blueprint. Ensure it uses the SCAM off-road skeleton. Name the blueprint. Open the animation blueprint. Add an input pose node. Add a control rig node and assign the appropriate control rig class. Create 4 float variables to store the suspension positions for each wheel. Make sure that the Use Pin checkbox is clicked on. This allows the blueprint to override the transforms. We now connect each wheel variable to the Z position on the control rig transform node. Later, these variables will store the suspension position of each wheel of the actor blueprint. Compile and save the animation blueprint. We are now ready to put everything together in the actor blueprint. Open the actor blueprint. We only need the event tick, so delete all other events. Add a skeletal mesh get node. Get the animation node and cast it to the off-road animation instance. Set each physics wheel variable to its respective suspension variable that is acquired from each wheel joint. compile, and save. We should now have a functional off-road vehicle with suspensions. The vehicle is still not drivable. That's the topic for another video. Go to the level editor and place one or more instances of the blueprint and test it. Tweaking the model is an important part of the process. Notice that there are big gaps between the chassis and the tires. This could be problematic when colliding with dynamics props or other vehicles, as other rigid bodies can get wedged in between. To fix this, we'll go back to the blueprint and add 2 collision boxes to act as fender. Open the blueprint, enable Show Debug, and select the chassis mesh. Add a Newton collision box and position it to cover the upper position of the tire and the corresponding side of the chassis. Duplicate the box and place the new one on the other side of the chassis. Go to the level editor again and stress test the blueprint. Pay attention to the behavior. This demo does not represent a fully drivable vehicle. In the next video, we'll cover a more efficient way to create vehicles and complex setups with rigid bodies and joints that can be controlled by a player. This demo focuses on how to rig objects with physics and animation. Thanks for watching, and see you in the next one.